In the deep sky, where darkness stretches like an eternal and silent ocean, the story began with an omen. NASA's radars and telescopes, accustomed to probing the inconceivable distances of space, caught sight of a visitor arriving from beyond, crossing the invisible frontier that separates our solar system from the infinite interstellar sea. This body was named 3I divided by Atlas. A dry, almost bureaucratic name, yet behind it lay the promise of revelation, the third recorded apparition of an object born outside the stars we know. But before human eyes could decipher its nature, the unexpected occurred. A blackout, not a simple technical glitch, not a predictable short circuit in a station's wiring, but a silence that spread with precision, as if obeying an unseen command. Telescopes shut down in cascade, communication systems collapsed like a house of cards, and NASA's control rooms, once alive with the hum of signals, sank into absence. It was as if space itself, for a brief instant, had closed its doors. The strangeness was not only in the sudden fall of the machines, but in the timing. All the failures converged on the very moment when the sensors fixed their gaze on the passage of 3I divided by Atlas. There was no coincidence here, but a hidden link that bound the interstellar traveler to the silence of human instruments. It felt as though the cosmos had chosen to defend itself, as though there existed a secret not yet meant for us, a cipher humanity was not prepared to decode. The blackout, instead of being a mere technical accident, became the inaugural signal of a greater enigma. What was it about this shard of rock and ice, born in distances too far to comprehend, that could bring NASA's electronic heart to silence? In that instant, the world was reminded of its fragility. We are creatures bound to light and information, sailing on fragile islands of knowledge amid an infinite ocean of the unknown. And in that moment, when the most powerful network of astronomical instruments, folded before a visitor from beyond humanity, felt the abyss opening beneath its feet. 3I divided by Atlas was no longer just a comet, no longer a drifting piece of frozen matter on a lonely voyage. It had become a mirror, reflecting humanity's inability to fully grasp what the universe hides within its silence. With each second, the systems remained unresponsive. Suspicion grew. We were not merely facing a malfunction, but an event striking at the very foundations of science. Thus began NASA's longest night, the night when the heavens refused to answer. And the mystery was not only out there among the stars, it had entered the very corridors of civilization, whispering that perhaps the cosmos speaks in ways we have yet to recognize. The arrival of 3I divided by Atlas was not born in silence but in the soft hum of ordinary observation. Astronomers, scanning the heavens with instruments designed to map the slow choreography of comets and asteroids, stumbled upon its presence. At first glance, it appeared to be yet another frozen wanderer, a comet dislodged from some distant reservoir of the solar system, but its trajectory betrayed it. The path was too steep, too swift, cutting across the gravitational field of the Sun in a way no local body could sustain. The numbers, when plotted, spoke with clarity. This object came from beyond. The designation 3I was not just a label, but a lineage. The first, 1I, Oumuamua, had startled the world with its cigar-shaped silhouette and baffling accelerations. The second, 2I divided by Borisov, arrived as a more familiar comet, trailing dust and gas, yet still carrying the sacred weight of being from elsewhere. Now came the third, Atlas, named after the survey telescope that glimpsed its arc across the sky. Each visitor was a page torn from a library that humanity could barely read. Scientists leaned in with awe. To see an object from another star system was to witness a messenger from places unseen, to touch material forged in alien nurseries of creation. These were the relics of worlds not our own, fragments thrown into the cosmic tide by forces billions of years old. In 3, I divided by Atlas, perhaps lay the chemistry of other suns, the fingerprint of distant planets, the dust of long-dead stars. The discovery came not with fanfare, but with quiet astonishment in control rooms where monitors glowed with data streams. Coordinates were exchanged, telescopes re-aimed, and observatories across continents synchronized their watch. Atlas was small, fragile in brightness, yet it carried with it the promise of revelations larger than galaxies. Each measurement, each spectral line, was a chance to peek into the unknown. But beneath the surface of excitement, there was also unease. For while Oumuamua and Borisov had come and gone without silencing the machines that studied them, Atlas carried a different weight. It was not merely its speed or path, but the subtle distortions in the data, the whispers of irregularity in the early observations. There was something restless in its presence, as though the cosmos itself stirred differently when it entered. And so, the stage was set. Scientists had found their visitor, their third messenger from the void. They had calculated its orbit, traced its path, and prepared to study it in detail. What they did not know was that Atlas would not give itself willingly to observation. It would demand a price, the price of silence. The first detections of 3I divided by Atlas seemed at a glance unremarkable. Astronomers are accustomed to finding faint smudges on their screens, threads of light against the black. Yet in the earliest observations, there was something that did not align with expectation. Its brightness shifted too quickly, not in the slow pulse of rotation, but in abrupt flickers, as if the comet itself were a lighthouse signaling in some forgotten code. The Pan-STARRS survey in Hawaii had captured the initial trace, a moving speck against the tapestry of stars. Within hours, other observatories confirmed it. Yet the confirmation carried dissonance. Each instrument registered Atlas differently. Some saw it brighter than it should have been, others dimmer, almost as if the object were cloaked in layers that changed depending on the angle of view. Astronomers ran the numbers. The orbital calculations did not lie. This body came from beyond the reach of the sun's gravity well, plunging inward with a speed only the galaxy could lend. It was an interstellar visitor, no doubt, but when its spectra were examined, the fingerprints of its material composition, the puzzle grew deeper. A comet should bear water, ice, carbon dioxide, dust. Atlas whispered other elements, traces that eluded neat categorization. Certain lines appeared in the spectrum where none should be, faint streaks as though belonging to atoms not expected in such abundance. The strangeness did not end there. As telescopes tracked it night by night, Atlas showed an unusual resilience. Typical comets flare and fragment as they near the sun, shedding material in glowing tails. Atlas, however, remained steady, almost resistant, releasing less debris than the models demanded. It was as if its structure carried a strength beyond the fragile norm of frozen wanderers. Reports accumulated, data from Chile, from the Canary Islands, from orbiting observatories all hinted at irregularities, a visiting body, but not behaving as a comet should. The excitement grew, tempered by a quiet thread of dread. Scientists recalled the lessons of Oumuamua, an object that defied categorization, sparking wild theories of alien craft and artificial design. Now, with Atlas, they stood once again on the edge of ignorance. The timing of the first anomalies would later haunt the narrative. For those faint signals, the spectral lines out of place, the light curves that shifted unexpectedly, were the earliest warnings. They were the whispers before the silence, omens written in data. Few realized, in those first nights of observation, that they were not merely watching a comet, but opening a door. And behind that door, darkness waited. Rarity defines the interstellar visitor. In the cosmic theater, most of the actors are bound to a single stage. The comets locked in Oort's distant halo, the asteroids tethered to the sun's gravity. the planets chained to predictable ellipses. But an object like 3I divided by Atlas is different. It does not belong. It crosses the solar system like a stranger passing through a town at night, unbound, uninvited, carrying the dust of another world. The odds of such an encounter are infinitesimal. Billions of years of stellar evolution scatter debris into interstellar space, but the void between stars is vast and merciless. For one of these fragments to drift near enough to be seen is a statistical miracle. Humanity has only recorded 3 in its history: Oumuamua in 2017, Borisov in 2019, and now Atlas. Each arrival is an anomaly, a fleeting glimpse of matter forged under suns we will never visit. Oumuamua was thin and elusive, accelerating in ways that defied gravity alone. Borisov was more cooperative, resembling comets we know, but still bore the mark of alien chemistry. Atlas arrived as if to merge the strangeness of the first with the familiarity of the second, yet exceeding them both. Its trajectory was sharper, its velocity higher, and its resistance to solar heating more profound. It seemed to carry the paradox of being both fragile and indestructible. Astronomers marveled at the implications. If each interstellar object is unique, then the galaxy must be littered with untold varieties of debris, exotic matter, alien minerals, perhaps even frozen remnants of biology from faraway systems. Each passing rock could be a sample from a cosmic archive older than Earth itself. And yet, these chances are so rare that every encounter is precious. Missing one means waiting perhaps decades, even centuries, before another messenger appears. That was why 3I divided by Atlas mattered. It was not only a body to be studied, it was a once-in-an-era opportunity. A chance to test theories about planetary birth, stellar collisions, and the chemistry of distant systems. A chance to hold a fragment of elsewhere. For NASA and every astronomer who turned their lenses toward it, Atlas was a gift the universe had rarely given. But gifts can conceal dangers. In its rarity lay also its strangeness, and in its strangeness, a threat. For the more they watched, the more Atlas defied the quiet categories. It began on the night NASA's Deep Space Network attempted a high-resolution scan of 3I divided by Atlas. Signals streamed back for a handful of seconds, faint reflections bouncing off the surface of the alien body before collapsing into static. Simultaneously, optical telescopes reported sudden blackouts in their imaging feeds, as though the light itself had been swallowed. Systems rebooted, only to fall again into darkness the moment Atlas reappeared in their field of view. Inside control rooms, confusion swelled. Technicians recalibrated instruments, checked power supplies, cycled satellites. Yet the pattern repeated with uncanny precision. Every attempt to fix the sensors faltered precisely when the comet was the target. Outside that frame, the systems ran flawlessly. Within it, silence. To those who witnessed the sequence unfold, the effect was almost theatrical. Screens that had moments before shown streams of data now glowed with emptiness. The hum of constant signal, the heartbeat of astronomy faltered and went still. Scientists, trained to believe in error margins and mechanical flaws, found themselves confronted with something harder to accept: the sense of an intelligence in the timing. Whispers spread across teams linked by radio. Was this interference? A solar storm? A hidden software corruption? But the solar weather was calm, the skies clear, the programs intact. The failures obeyed no terrestrial logic. Instead, they seemed tethered to the comet itself, as if its very presence was incompatible with observation. For those in the moment, it was terrifying. Not in the loud drama of catastrophe, but in the quiet certainty that the universe had closed its mouth. The realization spread slowly, chillingly, that Atlas was not merely evading detection, it was unmaking it. It was erasing humanity's ability to look. That night, the astronomers did not celebrate discovery. They sat in the glow of useless monitors, listening to the silence of machines that refused to see. What began as a night of study had become a vigil. Atlas passed overhead, unmeasured, unread, and the people who had spent their lives chasing the stars were forced, for the first time, to admit they had been denied. What unfolded in the hours that followed resembled not a malfunction, but a collapse, an unraveling of technology in cascading waves. One by one, instruments across the globe bent beneath the weight of the same invisible hand. Systems that had run faithfully for decades faltered as though struck by a silent storm. At NASA, the first reports came from the Goldstone antenna, deep in the Mojave Desert. Engineers watched in disbelief as the signal strength plummeted to zero, not gradually, but with the abruptness of a switch being flipped. Commands sent to reboot the system returned nothing but blank confirmations, responses that suggested activity but carried no information, like a machine speaking in an empty language. In Maryland, the Goddard Space Flight Center struggled to stabilize satellite links. Data from the Hubble Space Telescope froze mid-transmission, halting in the middle of spectral scans aimed directly at 3I divided by Atlas. Attempts to redirect the telescope to another star failed, not because the instruments disobeyed, but because they refused to acknowledge the command at all. It was as if the logic of the hardware itself had dissolved when confronted with the object. Even ground-based observatories, disconnected from NASA's direct systems, began to fall silent. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, smaller stations in Spain and South Africa all reported anomalies. Not hardware damage, not power failure, but a refusal to capture meaningful data whenever the comet entered the field of view. Outside that narrow frame, stars shone crisp and flawless. Inside it, nothing but void. The engineers spoke of cascading faults, but the rhythm was too precise. When one system fell, another followed within minutes, as if each were linked by some hidden tether. Observers noted the unnerving symmetry. Failures rose and subsided in harmony with Atlas's trajectory across the sky. No storm, no software, no random breakdown could account for such synchronicity. The silence grew heavy. Scientists, accustomed to treating malfunctions as puzzles to be solved, now found themselves staring at the possibility of intention. The failures seemed coordinated, as though Atlas carried not only alien chemistry, but an influence, a field of presence that unmade human attempts to see. The night stretched long. Teams worked without pause, hands trembling over keyboards, voices low with disbelief. Yet nothing held. Every attempt to look deeper into Atlas was repelled. It was not simply beyond reach, it was actively forbidding inquiry. In those hours, humanity learned a quiet lesson. Our instruments, the very eyes with which we claim to know the universe, are fragile things, and under the gaze of the unknown, they can be shut like lids over powerless eyes. The blackout spread like a contagion, and with it came the sudden paralysis of entire branches of research. For NASA, the silence was not an inconvenience but a wound. Instruments designed to capture the faintest whispers of the cosmos, the subtle glow of a dying star, the flicker of a distant exoplanet were rendered useless the moment they turned toward 3I divided by Atlas. What should have been weeks of uninterrupted observation dissolved into a void of absence. At first, mission directors tried to redirect resources. If Hubble could not see Atlas, then perhaps Webb would. If Webb faltered, then perhaps Chandra or Swift might step in. Yet the pattern was unyielding. Every eye that looked upon the visitor returned blind. The blackout was not selective in its victims. It consumed indiscriminately, spreading across disciplines from radio astronomy to optical imaging, from particle detection to cosmic ray monitoring. The cost was immediate and devastating. Years of preparation, calibrations, observation schedules, coordinated campaigns between international observatories were undone in a single night. Teams that had waited decades for the chance to study an interstellar body were forced to watch helplessly as the opportunity slipped through their fingers. The world's most advanced network of astronomical instruments, built through the labor of generations, had been reduced to silence by a rock no larger than a mountain. The frustration was laced with fear. If Atlas could shut down instruments merely by its presence, what did that imply about its nature? Was it emitting radiation unknown to physics? Was it interfering with the very quantum foundations of detection? Or was it something more deliberate, an intrinsic resistance to being observed, as though the object itself chose secrecy? Meanwhile, the scientific community fractured into urgency. Some argued for caution, warning that continued attempts might damage the instruments irreparably. Others demanded persistence, insisting that even corrupted data could hold clues. Yet all were united by the same unsettling truth. The blackout was not random. It followed Atlas like a shadow. In the silence, humanity glimpsed the fragility of its reach. Technology, so often celebrated as an extension of human will, proved impotent against a phenomenon that refused to be seen. For the first time in living memory, science was not halted by lack of imagination, but by the universe itself closing its doors. And so, Atlas drifted onward, unmeasured, unfathomed, trailing not a comet's tail of light, but a wake of broken systems and unanswered questions. The data that should have illuminated its nature remained trapped in darkness, and the world was left with the uncomfortable knowledge that some truths do not yield to inquiry, they resist it. The silence surrounding 3I, divided by Atlas, awoke memories of another enigma, one still lingering like an open wound in the scientific imagination. Just a few years earlier, in 2017, the world had watched the first confirmed interstellar object, 1I, Oumuamua, glide through the solar system. It was a visitor whose shape and behavior had unsettled astronomers, elongated like no comet ever seen, accelerating in ways no gravity could explain, slipping past telescopic scrutiny as if deliberately evasive. Oumuamua had sparked theories both grounded and wild. Some saw it as an icy shard torn from a distant planetesimal disk. Others dared to whisper of artificial origins, of a probe sent by distant intelligences. No evidence was ever conclusive, but the unease it seeded never left. Humanity had looked upon the first messenger from the stars and found itself unable to name it. Then came 2I, divided by Borisov, in 2019, a comet more familiar in nature, trailing gas and dust like the icy nomads we know. It reassured some, proving that not every interstellar wanderer would mock our understanding. Yet even Borisov carried chemical quirks hinting at alien processes of formation, subtle reminders that other star systems follow recipes we do not. Now, with 3I divided by Atlas, the comparisons were inevitable. Scientists remembered the strange silences of Oumuamua, its refusal to reflect expected spectra, its elusiveness to radar, and saw in Atlas an echo amplified. Where Oumuamua had been enigmatic in its absence of data, Atlas was aggressive in erasing it. Where Borisov had played the role of a cooperative guest, Atlas had arrived like a guardian of secrets. The echoes unsettled the mind. What if these objects were not random debris, but stages in a larger story? Messengers, each more defiant than the last, each tightening the circle of mystery around humanity's attempts to measure the cosmos? Oumuamua had whispered, Borisov had hinted, and now Atlas seemed to shout not in light, but in silence. As researchers revisited archived data from those earlier encounters, they noticed patterns they had once overlooked. Glitches in instruments during Oumuamua's passage, fleeting irregularities in Borisov's light curves, small details dismissed at the time as noise. Now, in the wake of Atlas, those fragments looked less like coincidence and more like preludes. Perhaps the blackout was not an isolated event, but the culmination of warnings humanity had failed to hear. The scientific community began to feel the weight of continuity, a thread woven through the arrivals of these rare visitors, linking them in a narrative not yet understood. Atlas was not just the third. It was the loudest reminder yet that the universe might not reveal itself on our terms. Fear, in science, does not usually announce itself with screams or sudden collapses. It seeps in quietly, through equations that refuse to balance, through data that will not yield to interpretation, through the unsettling silence of machines built to listen to the stars. The blackout tied to 3I divided by Atlas did not merely disrupt observation, it unsettled the very philosophy of astronomy. For centuries, humanity's pact with the cosmos had been simple. If we build better instruments, the universe will answer with more light, more detail, more truth. Each telescope was a promise of clarity, each detector a bridge across the abyss. Yet in the presence of Atlas, that pact fractured. The instruments did not break. They obeyed every command until they looked at the comet. Then they fell mute, as though acknowledging a law higher than engineering. The strangeness terrified because it suggested that the mystery was not a matter of human failure, but of cosmic resistance. The object seemed to erase inquiry itself, casting darkness not only across screens, but across certainty. Astronomers whispered, some reluctantly, that Atlas behaved almost as though it carried intent, as if observation were forbidden, not by accident, but by decree. The implications spiraled outward. If something as small as a comet could impose silence on global infrastructure, what did that say about the laws that govern reality? Could Atlas be interacting with physics at a level beneath detection, tampering not with machines, but with the very principles by which machines sense? Was this interference quantum, gravitational, or something entirely unimagined? Beyond the laboratories, the story gripped the public. News outlets spoke of NASA's dark night, of the blackout that coincided with the alien visitor. To some, it was a symbol of fragility, a reminder of how little we control in a universe that dwarfs us. To others, it was a threat, an omen that humanity was trespassing into realms it was never meant to enter. In the corridors of research centers, unease deepened. The fear was not of disaster in the physical sense, not of explosions or collisions, but of encountering a phenomenon that stripped science of its primary weapon, observation. Without sight, without data, the enterprise of understanding collapses into helplessness. Atlas was not destroying cities, but it was dismantling certainty. And in that dismantling, there lay something more frightening than catastrophe. The possibility that the universe itself may choose to remain unknowable. For the first time in generations, scientists looked up at the night sky and felt not wonder but exclusion. They were reminded that the cosmos is not obliged to reveal its secrets, and sometimes it answers inquiry with silence. Amid the spreading blackout, fragments of data survived like shards of pottery salvaged from the ruins of a collapsed temple. They were incomplete, scattered, sometimes corrupted, but they held enough substance to remind scientists that before silence fell, Atlas had already begun to whisper. Some of the earliest images captured by pan-stars in Hawaii and later confirmed by smaller observatories in Europe showed brief but sharp flares of light, irregular pulses that did not match the usual activity of a comet venting gas. These flares were not aligned with its orbit, nor with sunlight striking its surface. Instead, they seemed to emerge at strange intervals, as though governed by a hidden rhythm. Spectral readings, though truncated, revealed anomalies. Water, ice, and carbon dioxide were present, expected signatures of a cometary body, but layered over them were lines that did not fit. Faint traces of heavier elements appeared where none should be abundant. Some researchers suspected instrument contamination. Others pointed out that the same irregularities appeared across geographically separated observatories, suggesting they belonged not to the machines but to Atlas itself. Radio telescopes provided perhaps the most haunting clues. Just minutes before their receivers went dark, they recorded bursts, brief spikes in frequency, sharp and narrow, unlike natural emissions from comets or asteroids. The signals were not strong enough to suggest communication, yet they were too structured to dismiss as noise. Their abrupt cessation coincided precisely with the onset of blackout. These fragments were treated like relics. Scientists scoured them, running simulations, testing against databases of known materials, searching for mundane explanations, yet the pieces refused to fit together. The anomalies did not resemble the behavior of icy debris, nor did they resemble known interstellar signatures. They were something else, an echo without origin. What unsettled the researchers most was not the anomalies themselves, but their incompleteness. The data ended midstream, cut short, as though the act of observation itself had been amputated. It was like reading half a sentence from a language you cannot fully translate, knowing that meaning lay just beyond the point where the page had been torn. For the public, the loss was framed as a failure of machines, but for those who worked in the silence, the fragments became talismans. Each number, each pixel of distorted light, was a reminder that Atlas had not come empty-handed. It had shown just enough to reveal its difference, then closed the curtain before the performance was understood. And so, in archives and encrypted servers, these scraps were guarded with reverence. They were not proof, not yet, but they were the last words heard before the silence, and perhaps the only key humanity would ever hold to decipher what Atlas had been. From the salvaged fragments, one detail refused to be ignored: the spectrum of three, I divided by Atlas. Every comet reveals its identity through light split into colors, a celestial fingerprint etched in emission and absorption lines. But Atlas's spectrum seemed to bend the rules. In its early moments of observation, before the blackout swept through, telescopes captured faint traces of water vapor, the expected sigh of a comet's icy body as it neared sunlight. Carbon monoxide and carbon dioxide followed, signatures common to frozen wanderers. Yet beneath these familiar notes lurked others, lines that did not align with the periodic table as it is known. The strangeness came not from the absence of expected elements, but from the presence of excess. Lines appeared faintly where none should exist, traces suggesting isotopes in unusual abundance, whispers of molecular bonds rarely stable in such conditions. Some lines seemed shifted, displaced ever so slightly from their predicted positions, as though bent by an unknown force. At first, scientists suspected calibration errors. Instruments are sensitive to heat, to dust, to the whims of atmospheric interference, but the irregularities persisted across multiple observatories separated by oceans. The distortions were real. Speculation began to bloom. Could Atlas be carrying matter forged in exotic stellar environments, material older than the sun itself? Could it be laced with isotopes born in supernovae, or even stranger events, neutron star collisions, gamma-ray bursts? Each possibility suggested a history stretching back to cataclysms far from Earth, a history written into its very atoms. More unsettling still was the coherence of the anomalies. The spectrum did not appear chaotic, but patterned, as if the composition were ordered in ways that defied randomness. A comet should be messy, a relic of primordial dust. Atlas seemed too precise, its spectral irregularities clustered in deliberate harmony, as though they carried a hidden structure. To some, the thought arose quietly, reluctantly, that perhaps the lines were not natural at all. Could they represent interactions with fields unknown to physics, or even an encoded signal woven into chemistry itself? The idea felt dangerous, yet it lingered. For when scientists peered at Atlas, they were not merely looking at frozen dust, but at the possibility of matter itself being used as language. In the end, the spectrum became another silence. The data stopped flowing before the questions could be tested. What remained were ghostly graphs, incomplete yet haunting, curves that hinted at secrets and then cut off like interrupted speech. Atlas had given humanity a glimpse, then withdrawn into the dark. The mystery was no longer only in its motion or its silence, but in the very fabric of its substance. It was as though the object itself was built from questions, and every attempt to answer them only deepened the unknown. From the incomplete data, another layer of mystery emerged: anomalies in the electromagnetic whispers of 3I divided by Atlas. Comets normally speak through familiar tongues, the radio hiss of water vapor breaking apart, the ultraviolet shimmer of solar radiation ionizing their gases. Yet the signals linked to Atlas carried an alien rhythm, as though a different kind of energy threaded through its core. Radio telescopes, moments before the blackout struck them, had recorded sudden bursts, sharp spikes in narrow frequency bands. These spikes did not scatter like the broad static of natural emissions. They appeared tightly confined, like the plucked strings of a single instrument. They rose abruptly, vanished abruptly, leaving behind silence as profound as their emergence had been brief. Even stranger were the magnetic readings. Instruments tracking solar wind interactions noted fluctuations that could not be traced to the sun's activity. Local fields seemed to ripple whenever Atlas passed within view, as if the object carried an aura of distortion around it. These ripples were subtle, faint enough to be dismissed as noise under ordinary circumstances, but they recurred with eerie precision, timed to the comet's trajectory like shadows tethered to its path. Theories multiplied. Some physicists suggested Atlas might be coated in unusual minerals, exotic conductors that interacted with solar radiation in ways unfamiliar to terrestrial chemistry. Others wondered if it carried a charge, building and releasing electrical energy like a drifting capacitor in the void. Yet the spikes defied these explanations. Their crisp narrowness was too unnatural, their rhythm too deliberate. One unsettling hypothesis took root among a minority of researchers, that the signals might not be emissions at all, but interactions, not energy released by Atlas, but distortions caused when human instruments attempted to measure it, as though the object itself repelled observation, twisting the act of detection into something that collapsed upon itself. In this view, the spikes were not messages but warnings, the electromagnetic equivalent of a door slamming shut. The notion unsettled because it implied intent, or at the very least a law of physics not yet recognized. If Atlas carried within it a property that silenced machines, then the blackout was not an accident of engineering. It was a natural consequence of trying to see what was not meant to be seen. In hushed discussions, some dared to link these anomalies to darker mysteries, to the unmeasured realms of dark energy, to the trembling instability of quantum fields, to the possibility of hidden dimensions brushing against our own. The comet's presence was too brief to prove such claims, yet the associations lingered. For every fragment of electromagnetic data seemed to point not toward comprehension, but toward exclusion, as if the universe itself had rules of secrecy written into its fabric. And so, in the electromagnetic susurros of 3I divided by Atlas, humanity heard not only the voice of the unknown, but the echo of refusal. A refusal to be understood, a refusal to yield its secrets. It was the cosmos speaking softly and saying no. Gravity is the oldest language of the universe, a silent thread pulling stars into galaxies, planets into orbits, and comets into long, graceful arcs. It does not deceive, it does not falter. Its equations, drawn by Newton and reshaped by Einstein, have guided humanity with unbroken fidelity. Yet in the case of 3I divided by Atlas, even gravity whispered something strange. The first orbital models drawn from early detections should have traced a clean path, a hyperbolic arc slicing through the solar system, its shape dictated by velocity and the pull of the sunday, but the numbers, when refined, carried small distortions. Atlas was not precisely where it should have been, its trajectory bent in subtle, inexplicable ways, as if an unseen hand nudged it off course. Astrometric data gathered before the blackout showed deviations too large to dismiss as mere error. The margins of uncertainty were well understood, the calibrations tested. Yet Atlas drifted, its position shifted by fractions that grew into kilometers across days. The path was no longer cleanly hyperbolic, but restless, unsettled, as though the laws of motion bent uneasily around it. Astronomers remembered Oumuamua. That first interstellar visitor had accelerated unexpectedly, defying gravitational predictions. Some argued it was the effect of outgassing jets of vapor too faint to see, pushing the body like invisible thrusters. But with Atlas, no such jets were observed. Its surface showed little sign of activity, no trails of dust or water robust enough to explain the shifts. What then was steering it? Speculation reached toward the unsettling. Perhaps Atlas carried density variations, heavy elements clustered in strange distributions, warping its gravitational response. Or perhaps its interaction with solar radiation was governed by materials unknown, altering its motion in ways no comet had shown before. Yet even these answers felt thin, unsatisfying. The deviations carried an eerie consistency, bending always in alignment with the blackout events. When telescopes fell silent, Atlas's orbit seemed most distorted, as if the two phenomena were entwined. Gravity itself appeared to falter in the presence of this object, as though space-time bent differently in its shadow. To those who believed in patterns, this was more than coincidence. It hinted at the possibility that Atlas was not merely matter adrift, but matter wrapped in influence, an object whose presence distorted not only instruments, but the very fabric of the cosmos around it. For scientists who had built their careers on the precision of celestial mechanics, the realization was terrifying. If gravity itself could be unsettled, then no law was safe. Atlas had not only silenced machines, it had raised the possibility that the most faithful force in the universe might stutter in its presence. And so, the question deepened. Was Atlas bound by the same cosmos as us? Or did it carry the imprint of a different one, a gravitational fingerprint from beyond the borders of our reality? The blackout might have been explained away as coincidence. The spectral anomalies could have been blamed on calibration errors. The gravitational deviations might have been smoothed into the margins of uncertainty. But when the threads were woven together, the pattern became undeniable. The silence, the distortions, the flickering spectra all appeared only in relation to Atlas. The comet was not simply passing through, it was shaping the act of observation itself. Every glance humanity directed at it seemed to invite interference, as if its very presence refused exposure. Scientists who had spent careers parsing noise from truth began to see Atlas not as an object, but as an event, an interaction between the known universe and something that did not belong. The deeper they looked, the deeper the mystery grew. Logs revealed that even instruments not directly focused on Atlas occasionally faltered when its trajectory brought it near their field. Satellites monitoring cosmic rays, for instance, registered uncharacteristic dips during its passage. Detectors measuring background microwave radiation recorded faint interruptions, as though the cosmic afterglow of the Big Bang itself dimmed in its proximity. This was not the behavior of inert rock and ice. It was intrusion, a ripple through systems not meant to be touched. Atlas's presence seemed to bend not only gravity but perception, seeping into every method humanity used to see the cosmos. The effect unsettled the core of astrophysics. Observation is supposed to be passive. Instruments do not alter the stars they study. Yet with Atlas, the very attempt to measure became destructive, erasing data as quickly as it was sought. It was as though reality itself, in Atlas's vicinity, recoiled from scrutiny. Such a thought carried implications heavier than stone. If Atlas was bound to phenomena that resisted observation, then perhaps it brushed against the same riddles haunting physics today. Dark matter, unseen yet everywhere. Dark energy, driving cosmic expansion, yet invisible to all eyes. Could Atlas be linked to these unseen forces, not as metaphor, but as mechanism? For those who dared to wonder, a terrifying possibility emerged. Perhaps Atlas was not silencing instruments at all. Perhaps it revealed that the universe contains regions where the act of measurement itself collapses, where information cannot be extracted without vanishing into void. In such places, even light may be untrustworthy, even gravity uncertain. The blackout was no longer a malfunction. It was a boundary, a line between what humanity could know and what it was forbidden to touch. And Atlas, in its brief passage, had brought that boundary to our doorstep. The unease that surrounded Atlas soon fermented into hypotheses, some cautious, others unsettling, all haunted by the same sense of intrusion. Scientists, though reluctant to voice speculation without proof, began to sketch possibilities in hushed conferences and encrypted exchanges. What if the blackout was not mechanical but deliberate? One idea suggested that Atlas carried with it an electromagnetic field unlike any encountered before, capable of overwhelming detectors not by brute force but by subtle interference. If true, then the comet was not simply reflecting sunlight, it was radiating a veil, a kind of cloak that erased its own image from the skies. Such a phenomenon could emerge from exotic materials, superconductors forged in alien stellar furnaces, or from states of matter that Earth had never witnessed. Another theory, more daring, whispered of technology. What if Atlas was no comet at all, but an artifact disguised as one? A probe or a derelict vessel, its camouflage so perfect that only its effects betrayed it. The blackout, in this telling, was not a side effect, but a defense mechanism, a curtain drawn over its true nature. The suggestion recalled Oumuamua's strangeness and reignited debates about artificial origin. Few dared publish such claims, yet the thought lingered in every discussion. Some physicists reached for more radical explanations. Could Atlas interact with space-time itself, altering the local quantum fields that allow measurement? In this view, its presence might collapse probabilities in ways no detector could withstand, producing silence not through force, but through the erasure of possibility. The comet would then be less an object than a phenomenon, a traveling anomaly of physics, an emissary of laws unimagined. These ideas terrified as much as they intrigued. If Atlas carried hidden technologies, then humanity was being observed. If it bent the fabric of measurement, then our tools were not broken but inadequate. Either way, the blackout seemed to mock human inquiry, as if declaring, "You are not ready." Yet among the silence, the fear, and the secrecy, a truth began to crystallize. The blackout was not incidental. It was tied to the nature of Atlas itself. And whether natural or constructed, whether by physics or design, It meant that the object carried within it a purpose, or at least the shadow of one. To face that shadow was to confront a possibility few had dared to imagine, that the universe does not merely surprise us, but at times actively resists us, that some visitors do not come to be understood, but to remind us of the limits of understanding. The deeper researchers probed the blackout, the more a disturbing idea took hold. Perhaps 3I divided by Atlas was not just a visitor of rock and ice, but a fragment entangled with the unseen scaffolding of the cosmos itself. Its silence, its distortions, its refusal to be measured, these bore uncanny resemblance to the great invisible forces that haunt modern physics. Dark energy was the first comparison. This mysterious presence, thought to drive the accelerating expansion of the universe, has never been directly observed. It is known only through its effects, a ghost written into the stretching of galaxies. Some scientists wondered, what if Atlas carried with it a shard of that same enigma? If its motion and interference resembled the fingerprints of dark energy, then perhaps the blackout was not a defense, but a symptom, a local rupture in the balance between matter and void. Others turned to the quantum fields that underpin reality. Every particle, every atom, exists because of invisible seas of energy pulsing at the smallest scales. Could Atlas be coated or infused with an exotic state of matter, one that disturbed these fields in ways ordinary detectors could not survive? If so, then its blackout effect might not have been aimed at us. It could have been the inevitable consequence of matter shaped by alien quantum conditions. More radical still was the speculation about the false vacuum. Physics holds a terrifying possibility that our universe exists in a precarious state, a bubble of unstable energy that could collapse into a lower energy reality. If Atlas had formed in a different quantum vacuum, if it carried within it the physics of another cosmic regime, then its very existence could destabilize local space. The blackout, in this view, might have been the trembling of space-time itself, recoiling from contact. To philosophers of science, this raised an even darker implication. What if Atlas was not unique, but merely the first messenger of a greater truth, that the void between stars is seeded with fragments of incompatible realities? That every so often, the solar system is brushed by matter from another order of existence, leaving behind silence where our laws of physics fail? The thought was almost unbearable. To study Atlas might be to risk exposure to truths the universe itself does not permit. The blackout became not only a mystery of astronomy, but a metaphor of boundaries. Beyond it lay forces so alien that even the instruments of our age could not survive the encounter. And yet, despite the dread, fascination persisted. For if Atlas truly brushed against dark energy, quantum instability, or false vacua, then it had offered humanity something priceless, the faintest touch of the architecture that shapes everything. In its silence, perhaps, was the loudest clue yet to the hidden nature of reality. When the blackout was mapped against the familiar laws of physics, one name returned like an echo: Einstein. His general theory of relativity has stood for more than a century, describing how matter bends space-time and how gravity is nothing more than geometry written large. It has guided spacecraft to distant planets, explained the orbit of Mercury, and predicted black holes whose existence was later proven by light itself. Yet, in the shadow of 3I, divided by Atlas, even Einstein's elegant equations seemed to hesitate. Relativity relies on observation. Mass curves space, light follows those curves, and measurement confirms the pattern. But Atlas resisted this dance. Its orbit bent subtly in ways unaccounted for, as if space-time itself warped differently in its presence. Telescopes searching for gravitational lensing effects, tiny distortions of starlight caused by Atlas's pull, found inconsistencies. The lensing was weaker than expected at times, stronger at others, and on several occasions vanished entirely, as though Atlas were alternately heavy and weightless. The paradox was profound. Nothing in Einstein's framework allows for such variability. Mass does not flicker. Gravity does not shift like a tide under hidden moons. Unless, of course, Atlas carried with it more than mass, perhaps fields or energies that altered how space-time recognized it. In this possibility, Atlas was not simply an object, but a distortion, a portable rift in the fabric of relativity itself. Some physicists whispered of parallels to the anomalies seen near black holes, where light and information seem to disappear at the event horizon. Could Atlas represent a fragment of such extreme conditions, carried from the outskirts of collapsed stars or born in environments where relativity strains to breaking? If so, then the blackout was less a failure of instruments and more the natural consequence of looking into space-time's blind spot. Einstein's ghost seemed to linger in every debate. His theories had expanded human vision, turning the cosmos into a map that curved and rippled. But here was an object that seemed to bend even those rules. If relativity described the scaffolding of reality, then Atlas suggested that scaffolding might not be universal. There could be structures of space and time beyond Einstein's reach, frameworks invisible until a visitor from another star brushed against ours. The thought was both exhilarating and terrifying. Exhilarating because it promised new physics beyond the greatest genius humanity had produced. Terrifying because it implied that our universe is only one interpretation of the deeper order, a local dialect of laws that might be silenced when another dialect intrudes. In Atlas, relativity found its shadow, and in that shadow, humanity glimpsed not the comfort of equations, but the abyss of possibilities where even Einstein could no longer guide us. Stephen Hawking once warned that the greatest mysteries of the universe are not found in the light of stars but in the silence around them. He spoke of black holes as paradoxes, regions where information appears to vanish, where the laws of physics are stretched until they fray. In the blackout caused by 3I divided by Atlas, many scientists felt the haunting echo of Hawking's words. The parallels were unsettling. A black hole erases data by swallowing it beyond its event horizon, leaving only faint traces in radiation. Atlas, too, erased data, but in a different way, not by devouring signals, but by collapsing the ability to record them at all. The similarity was enough to stir whispers that Atlas might share something with the physics of horizons, that it might carry within it the same kind of boundary between knowledge and silence. Hawking's ideas about information loss resonated here. If a black hole consumes information, does the universe preserve it somewhere, or is it lost forever? Atlas seemed to pose a similar question. When instruments turned toward it and failed, where did that lost information go? Was it blocked, scattered, or diverted into realms beyond human reach? The blackout was like a miniature event horizon drawn across every telescope lens. Some physicists dared to speculate that Atlas might be a fragment of collapsed reality itself, a shard ejected from violent events near a black hole, bearing within it the physics of horizons. Its gravitational irregularities, its spectral strangeness, even its silencing of instruments, could be signs of matter forged under conditions that tested the limits of relativity. In this vision, Atlas was not merely foreign to the solar system, it was foreign to the stability of space-time itself. Others recalled Hawking's meditations on the instability of the cosmos, his suggestion that quantum fluctuations could, in theory, tear open new universes or dissolve the old. What if Atlas brushed against such instability? If it carried within it a reminder that reality is precarious, then the blackout was more than mystery, it was warning. To those who had long revered Hawking, the connection felt poetic, even cruel. His life's work was devoted to illuminating the paradoxes at the edge of knowledge, and here was a comet that seemed to embody them. Atlas silenced instruments the way an event horizon silences light. It mocked the human need to measure. to prove, to know. In that silence, Hawking's legacy seemed more relevant than ever. Perhaps the universe does not surrender all its truths. Perhaps some phenomena exist not to be understood, but to remind us of our limits. Atlas had become such a reminder, a drifting horizon, carrying the shadow of black holes into the open sky. The longer Atlas eluded explanation, the more theories emerged, each stretching the boundaries of physics until they strained. What began as cautious scientific debate swelled into speculation bordering on the metaphysical. For every researcher who sought to ground the mystery in chemistry and dust, another wondered whether Atlas pointed to a deeper fracture in the fabric of reality. One of the boldest hypotheses invoked the multiverse. If our universe is but one bubble in a vast cosmic foam, then matter from another domain might occasionally drift across the boundaries. Could Atlas be such a trespasser, born in a cosmos with laws subtly different from ours? Its resistance to observation, its gravitational irregularities, its spectral anomalies, all could be the residue of foreign physics bleeding into our own. In this view, the blackout was not just malfunction but incompatibility. Our instruments were tuned to one universe, and Atlas carried the imprint of another. Others pointed toward the concept of the false vacuum, the fragile idea that our universe rests not in its most stable state, but in a temporary plateau of energy. If true, even a small disturbance could, in theory, collapse reality into a lower energy form. Some scientists, speaking in hushed tones, suggested that Atlas might represent such a disturbance, a body crystallized in a different vacuum state. The blackout, then, might have been space-time shuddering in protest, a faint signal of instability too terrible to confront openly. Quantum field theorists saw another possibility. Perhaps Atlas was bound to exotic fields that interact only weakly with ours, hidden layers of reality, long suspected but never seen. If its presence stirred those fields, then detectors would not fail from mechanical fragility but from facing a truth beyond their design. The blackout was not destruction but exposure to physics no longer compatible with human perception. To many, these ideas seemed perilous, even reckless, yet they spread because each fragment of data refused to settle into comfort. Atlas was not behaving like anything in the known catalogue of astronomy. It forced imagination to stretch beyond the safety of precedent. The image that emerged was unsettling. If Atlas were natural, then nature itself harbored forms of matter and energy so strange they erased the tools meant to measure them. If it were artificial, then it implied intentioned beings or systems capable of cloaking themselves against entire civilizations. And if it was neither, if it was instead a phenomenon crossing from another order of reality, then humanity had brushed against a truth too vast to hold. In every theory, the conclusion was the same. Atlas was not an isolated curiosity. It was a message, though written in a language beyond comprehension. A message that said the cosmos is wider, darker, and stranger than we dare to believe. The blackout did not end curiosity. It ignited a new wave of desperation. If Atlas could not be seen through the usual lenses, then the task became to build new eyes. Across the world, scientists began to improvise, recalibrate, and reanimate their instruments, seeking ways to peer into the silence. It was a moment of urgency, of ingenuity, born in the shadow of failure. NASA's engineers were the first to act, reviving dormant satellites and redirecting them to Atlas's path. Missions long past their prime old weather monitors, decommissioned communication probes were patched into makeshift observatories. Their sensors were crude compared to the precision of Hubble or Webb, but they were outside the main network of telescopes and therefore uncorrupted by the chain reaction of the blackout. For a brief moment, fragments of data trickled through, imperfect but precious. Ground observatories attempted unconventional strategies, Some switched from optical to infrared, hoping to bypass the interference by capturing heat rather than light. Others turned to polarization filters, dissecting the faint glimmers of scattered photons as though searching for a hidden code. Every scrap of information became treasure. Every anomaly was studied not as failure, but as a clue. Physicists also looked to particle detectors, devices never intended to observe comets. The massive neutrino observatories buried deep in Antarctic ice were checked for unusual bursts. Cosmic ray monitors were recalibrated to catch any signal that might coincide with Atlas's passage. These instruments, divorced from traditional astronomy, became humanity's backup senses, ears pressed to the fabric of reality, hoping to hear what eyes could not see. Yet even with such efforts, the silence persisted. Some instruments showed flickers of interference, pulses and dips that suggested Atlas's shadow fell across them, but none could resolve the mystery into clarity. The blackout remained, more like a wall than a veil. Still, the attempts mattered. They proved that humanity would not retreat quietly. In every recalibration, every desperate restoration of old tools, there was defiance against the silence. Science, stripped of its usual triumphs, showed its rawest quality, persistence. And in that persistence, a new question arose. If the blackout could not be broken by the instruments of today, then perhaps it demanded technologies of tomorrow, detectors that measure not only light or gravity, but whatever hidden fields Atlas stirred. To face Atlas was to admit that the known arsenal of astronomy had reached its edge. Beyond it lay the need for invention, for tools forged to chase mysteries deeper than any before. In this way, Atlas became not only a visitor, but a challenge, a mirror, showing humanity the boundaries of its knowledge and daring it to step beyond. When the silence spread across NASA's instruments, one telescope became the beacon of hope, the James Webb Space Telescope. Newly deployed, floating 1,000,000 miles from Earth in the cold safety of L2, Webb was humanity's sharpest eye, capable of peeling back veils of dust and gazing into the first moments after the Big Bang. If anything could pierce the shroud of Atlas, surely it would be Webb. Requests flooded through the observing committees, emergency proposals, urgent recalibrations, overrides of planned programs, all funneled toward one aim: turn Webb toward Atlas. The telescope, built with gold mirrors polished to near perfection, aligned itself with the faint trajectory of the visitor. Engineers braced for either triumph or another collapse. For a brief span, light arrived. Webb's instruments captured narrow bands of infrared glow, signals unlike those from ordinary comets. Instead of the expected signature of frozen water and carbon monoxide, there appeared a broken spectrum, jagged and incomplete, as though light itself had been fractured passing through the object. For a heartbeat, humanity thought it had finally glimpsed Atlas's truth. And then Webb too fell silent, not destroyed, not offline, but paralyzed. Its sensors froze mid-scan, refusing to relay further data. Command signals reached the telescope but returned void responses, empty acknowledgements without content. The blackout had reached even this sentinel beyond Earth, touching the most advanced instrument humanity had ever placed in the sky. The silence lasted only hours, but in those hours, Webb became a ghost alive, yet unable to speak. Engineers at the Space Telescope Science Institute worked feverishly, fearing permanent damage. When communication finally resumed, Webb was unharmed, its systems flawless, but the data it had gathered in its stare at Atlas was gone, erased as though never recorded. Only a handful of corrupted frames remained, fractured images that hinted at complexity without revealing it. The effect was devastating. If even Webb could not penetrate Atlas's veil, then the mystery had surpassed the pinnacle of human observation. The telescope designed to look back across 13 billion years of cosmic history had been silenced by a fragment drifting through the solar system. Yet the attempt left more than despair. Those corrupted frames, though incomplete, bore strange features, faint patterns within the jagged spectra, alignments that some believed too deliberate to be random. Though inconclusive, they reignited debates. Was Atlas natural but exotic, or was its silence intentional? For many, Webb's silence became symbolic. Humanity had built its greatest eye, and the universe had closed it. In that refusal, there was a lesson perhaps, a warning that even the sharpest instruments cannot demand revelation. The cosmos will yield its truths only on its own terms. As Atlas drifted deeper into the solar system, the blackout was no longer a problem for NASA alone. Around the globe, the great network of satellites and observatories turned their attention toward the visitor, hoping that together they might break its silence. Coordination replaced competition. European, Asian, and South American observatories aligned their schedules with American ones, while private space agencies opened their archives to the effort. The world, for a rare moment, watched the same object with a single gaze. Satellites already orbiting Earth were repurposed. Weather satellites, designed to track clouds and storms, recalibrated to scan the faint glow of Atlas in wavelengths beyond visible light. Communication satellites, with sensitive receivers tuned to the faintest frequencies, were drafted as passive listeners, straining for whispers of energy from the visitor. Even instruments on probes bound for Mars and Jupiter were redirected, their sensors pointed homeward to catch a glimpse of the interstellar trespasser. The results were strangely consistent. Whenever Atlas entered their line of sight, anomalies followed. Data packets failed mid-transmission. Images arrived corrupted, their pixels smeared into meaningless static. Onboard clocks drifted out of sync as though time itself stuttered in the presence of the comet. Some satellites even reported brief lapses in orientation, gyroscopes spinning off calibration, as if their internal sense of up and down had been bent by invisible hands. The effect was not destructive. No satellite was lost, no hardware permanently damaged. Instead, the blackout behaved like a shadow, touching instruments only when they sought Atlas, lifting as soon as their attention moved elsewhere. It was selective, precise, as if observation itself was the trigger. This unnerved the scientists even more than total failure would have. A machine that breaks can be repaired. A shadow that chooses when to fall suggests law or will. Was Atlas broadcasting interference? Or was its very existence incompatible with the mechanics of human technology? In the wake of these patterns, international agencies began to treat the blackout as a coordinated phenomenon. Data-sharing agreements were drafted overnight. Signals were cross-referenced across continents, confirming that the anomalies appeared in perfect synchrony. No matter the instrument, no matter the nation, the silence struck at the exact same moments. What emerged was a chilling realization. Atlas was not merely silencing NASA, it was silencing the world. Every satellite in orbit, every observatory on Earth, every tool humanity had raised toward the sky, all spoke the same report. Where Atlas passed, the universe refused to be seen. While satellites and telescopes struggled in the face of silence, another front of inquiry opened on Earth itself. If Atlas disrupted instruments that sought to see it, perhaps it left behind traces in the invisible streams of particles that bathe the planet. Physicists turned to their great underground cathedrals, detectors buried in ice, in stone, in water machines, built not for comets, but for the hidden messengers of the cosmos. The Ice Cube Neutrino Observatory in Antarctica was the first to be checked. Its kilometers of sensors, frozen deep beneath the ice, listened constantly for the faint flashes produced by neutrinos colliding with matter. In the days when Atlas crossed into range, subtle anomalies appeared, not great surges, but small bursts of detections clustered strangely, as though a faint wave of unseen particles had passed through Earth. Their energy did not match solar neutrinos, nor those from distant supernovae. They were sharp, isolated, and eerily timed with the blackout overhead. Elsewhere, cosmic ray detectors in South America reported spikes of high-energy particles, brief showers that defied expected patterns. The Pierre Auger Observatory noted that some of these showers arrived not from the usual diffuse sources across the galaxy, but from a tight band in the sky, precisely aligned with Atlas's trajectory. Even the massive underground tanks of Super Kamiokande in Japan, filled with ultra-pure water and tuned to catch the faintest echoes of neutrinos, registered distortions in their data. The signals were faint, ambiguous, but undeniable. Something unusual had brushed against their instruments at the same hours Atlas was above. What unsettled scientists most was the suggestion of coherence. Particle detectors scattered across the world, independent, separated, unlinked, each recorded irregularities that aligned in time. It was as though Atlas radiated not only silence but a particle fingerprint, a shadow imprinted in forces invisible to ordinary senses. Theories multiplied. Some argued it was evidence of exotic cosmic rays, fragments of matter born in stellar furnaces beyond imagination. Others proposed interactions with hypothetical particles, actions, sterile neutrinos, or dark matter itself, seeds of theories long unproven. A few whispered that the signals could not be natural at all, that they resembled emissions modulated, patterned, like a code embedded in the rain of particles. No conclusion came. The data were fragmentary, as incomplete as the corrupted images from telescopes. But in the depths of the Earth, in machines meant to listen to the cosmos's quietest voices, humanity caught the faint suggestion of another presence. Atlas did not only silence, it left behind a residue, a ghostly trace in particles that might not even belong to this universe. For scientists, it was both gift and torment. Proof that something had touched their instruments, but not enough to say what. Like footprints at the edge of an abyss, the signals pointed to a visitor that had passed, but left only questions in its wake. Mathematics is the language of science, the net with which humanity catches the patterns of the cosmos. Equations hold the stars in their orbits, predict eclipses centuries in advance, and describe the fusion that burns within the sunday. For generations, math has been the comfort of certainty, the tool that tells us that, even in the vast unknown, there is order. Yet when 3i divided by Atlas passed, the equations bent. Numbers that should have aligned slipped into contradiction, and formulas once trusted fractured under the weight of anomalies. Astrophysicists tried to model its orbit using Newtonian mechanics, then refined their predictions with Einstein's relativistic corrections. Still, the path of Atlas resisted. Small deviations compounded into vast divergences. Simulations that should have converged towards certainty instead unraveled into chaos. The data would not stabilize. It was as though Atlas carried with it a rulebook of gravity foreign to our own, one that mathematics could glimpse but not contain. Spectral analysis, too, confounded the numbers. Chemical abundances derived from the fragments of data did not add up to unity, leaving missing fractions as though part of the comet's composition refused arithmetic itself. Equations of radiative transfer broke down, absorption lines appeared displaced, their ratios defying the simplest rules of quantum mechanics. Even statistical error margins, carefully calculated, produced results that mocked probability confidence levels greater than certainty, likelihoods that exceeded the very framework of chance. In particle physics, the anomalies deepened. Neutrino bursts detected during Atlas's passage produced calculations of energy that contradicted conservation laws, suggesting particles carrying more momentum than could be explained by their collisions. Simulations returned negative probabilities, impossible numbers that should never exist outside thought experiments. Yet there they were, etched into the readouts of the most precise detectors humanity had ever built. Mathematicians themselves began to speak in hushed tones of breakdown, not merely that the data resisted models, but that the models themselves seemed to collapse. Equations became unstable, generating infinities where none should exist, reminding physicists of the catastrophic failures encountered in attempts to merge quantum mechanics with relativity. The universe, in Atlas's presence, seemed to lean into those very cracks, widening them until the frameworks of logic groaned. It was not destruction of instruments alone, it was a corruption of the language meant to interpret them. The cosmos had always been vast, but never before had it seemed so unwilling to be written down. In this fracture of mathematics, many saw a mirror of the blackout itself. Atlas was not merely resisting observation, it was erasing coherence, as though the very act of applying numbers to it caused reality to recoil. The silence was no longer confined to machines. It had reached into the equations, leaving scientists staring not at answers but at the unraveling of their own tools. For the first time in generations, mathematics did not promise clarity. It whispered uncertainty, trembling under the weight of a visitor that carried within it laws too alien to be contained by numbers we thought eternal. As the days stretched into weeks, the scientific community began to admit what had once been unthinkable. There were no precedents for 3I divided by Atlas. Every known category of celestial object, asteroid, comet, rogue planet, failed to hold it. Every law tested against it faltered. The blackout was not an error of engineering, nor a quirk of calibration. It was a phenomenon that revealed the fragility of the very frameworks that science depends upon. At first, denial held sway. Teams argued fiercely in conferences and private correspondence, clinging to the hope that anomalies could still be forced into the margins of error. Perhaps the instruments had suffered unseen contamination. Perhaps stray solar radiation had disrupted signals. Perhaps the comet's chemistry was simply unusual, not impossible. But denial thinned with each attempt to reconcile the data. The evidence did not bend, it broke. The acknowledgement came slowly, painfully. Reports circulated in drafts, written with caution, their language restrained, unprecedented, unclassifiable, incompatible with current models. Behind those words lay a quiet fear, the recognition that science, for all its rigor, had reached a place where its maps no longer matched the territory. Some researchers described Atlas not as an object but as an event, a phenomenon that destabilized measurement, that twisted gravity, that bent spectra, that produced signals more like whispers of hidden fields than emissions of dust and ice. To call it a comet was to shrink it, to force the incomprehensible into a familiar box. Yet no new word arose to take its place. It was a thing without name. What made the admission most haunting was the silence it left behind. Other mysteries of the universe, dark matter, dark energy, black holes still yielded indirect evidence, still offered data to shape hypotheses. Atlas gave nothing. It arrived, resisted, and withdrew, leaving only fragments too incomplete to serve as foundation. In this way, it mocked the process of science itself. For many, this was more frightening than catastrophe. A collision could be explained, an explosion measured, but an absence, a refusal, left nothing to hold. Atlas had not destroyed instruments, it had dismantled certainty. It had shown that the pursuit of knowledge can reach a horizon beyond which nothing waits. In whispered conversations, scientists compared the experience to staring into a mirror that reflected not truth but ignorance. It was not simply that humanity did not know, it was that humanity could not know. Atlas became the emblem of that limit, the messenger of a silence more profound than the void between stars. And so, in reports and journals, in late-night meetings and empty observatories, the same truth spread. There was no precedent. Atlas was the first of its kind, and perhaps the last humanity would ever glimpse. A reminder that the universe, vast and indifferent, owes us no answers. As speculation deepened, the tone of the discourse shifted. The blackout was no longer spoken of merely as an astronomical event, but as something that brushed against the edges of human existence. If Atlas could silence the world's most advanced instruments, what else might it silence? If the laws of physics trembled in its presence, what shield did Earth truly possess against the unknown? In the halls of academia, debates turned uneasy. Some physicists argued that the blackout was benign, a passive consequence of matter alien to our universe, but others insisted it carried the shadow of risk. If Atlas represented a fragment of a different vacuum state, could its mere presence destabilize our own? If it bore exotic fields, could those fields spread, rippling through space-time like cracks in glass? The possibility of threat became impossible to ignore. A comet does not choose where it travels. Its path might carry it closer to planets, to satellites, to Earth itself. And if proximity alone was enough to collapse instruments into silence, what might happen if it brushed directly against the biosphere? Would the blackout spread beyond machines, touching the very chemistry of life? For the public, fear took on symbolic forms. Headlines called Atlas the Dark Star, the Cosmic Eraser, the Comet of Silence. Conspiracy forums whispered of alien weapons, of probes designed to cloak civilizations, of harbingers sent to test humanity's readiness. Even in more measured circles, the dread was palpable. For the first time, humanity confronted the possibility that a visitor from the stars might not merely be unknown, it might be unknowable, and dangerously so. Philosophers and theologians joined the conversation, their language different, but their concerns the same. If Atlas was more than stone and ice, then it had implications not just for physics, but for meaning. A cosmos that hides, that resists, that silences. What did that say about the nature of existence itself? Was Atlas a natural reminder of limits, or a deliberate signpost placed by something greater? The sense of danger was not of imminent destruction, but of existential fragility. Atlas did not crash into Earth, did not rain fire across the sky. Its threat was subtler. The suggestion that the reality we depend upon could be rewritten in an instant, that our science might prove powerless when confronted with phenomena beyond comprehension. In this way, the fear surrounding Atlas transcended astronomy. It was not about a comet, it was about the possibility that reality itself holds fissures, and that one of those fissures had passed close enough for humanity to glimpse. The fear was not only that we could not understand, but that perhaps we should not. As the weeks turned into months, and Atlas slipped further along its course, the frenzy of observation gave way to reflection. Scientists, stripped of data, found themselves speaking not only in equations but in metaphors. The blackout had become more than an astronomical event. It was a philosophical wound, a reminder that knowledge is fragile and that silence can be as profound as revelation. The comet's refusal to be measured was interpreted less as a failure of technology and more as a parable of existence. For centuries, humanity has believed that with enough persistence, the universe would yield its secrets. Yet Atlas showed another possibility, that there are truths which do not consent to being known. In its wake, silence became more eloquent than discovery. Some thinkers compared the blackout to the ancient myth of forbidden fire, stolen by Prometheus from the gods. Humanity has always reached beyond its grasp, clawing at the fabric of the unknown. But Atlas seemed to suggest that the cosmos carries its own boundaries, lines not drawn by human frailty but by reality itself. The silence was not only technical, it was a cosmic no. Philosophers of science began to ask unsettling questions. If Atlas resists observation, does it reveal something about the nature of reality itself, that the act of looking can be destructive, that some phenomena vanish when pressed for answers? Quantum mechanics had already suggested this with its principle of uncertainty, but Atlas seemed to embody it on a cosmic scale. A comet that collapses the very attempt to see it, what does that say about the relationship between consciousness and the universe? In poetry, the blackout was described as a mirror. The cosmos did not reflect stars, but our own ignorance, staring back at us with patient indifference. The silence of Atlas was interpreted as a metaphor for the human condition. We are creatures who hunger for answers in a universe that speaks rarely, and often in riddles. Theologians, too, found language in the silence. Some called it a sign that the universe still guards mysteries sacred, inaccessible, even to the most advanced instruments of human making. Others spoke of Atlas as a messenger of humility, a drifting sermon reminding humanity that we are not masters of the cosmos but its children, barely able to listen. And so the blackout transformed from technical anomaly into philosophy. It became a story not of failure but of meaning, a parable etched across the sky. For in refusing to be seen, Atlas forced humanity to see itself, fragile, yearning, and always at the edge of an abyss that will not answer. Long after 3I divided by Atlas had vanished from the night sky, its passage lingered not in images or measurements, but in memory. The event became myth within the scientific community, a whispered story passed down like a cautionary tale. Unlike comets of history that dazzled with light, Atlas was remembered for the darkness it cast, the first cosmic visitor to silence humanity's instruments. In lecture halls, professors spoke of it with reverence, presenting the fragments of corrupted spectra and incomplete orbits as relics of a vanished encounter. Students who had grown up hearing of Oumuamua and Borisov now carried the legend of Atlas as their own inheritance, the tale of the comet that refused to be known. Research papers continued to cite it, not for answers, but for the questions it left unresolved. For the public, the blackout became woven into culture. Novels, films, and paintings depicted Atlas as both omen and oracle. Some imagined it as a vessel cloaked in secrecy, others as a shard of a universe alien to our own. In art, Atlas was drawn not with the fiery tales of comets past, but as a dark silhouette moving through the stars, a symbol of mystery itself. In the quiet corners of astronomy, scientists returned to its data scraps like monks revisiting sacred texts. They spoke of the corrupted frames from Webb, the spectral lines that should not exist, the particle anomalies that aligned too neatly. None of it added to certainty, but each fragment carried the gravity of myth. Atlas became less a comet and more a threshold, a reminder that science, like myth, thrives not only on answers, but on mysteries that resist them. Even the language around it grew reverent. Researchers described the night of silence, the visitor of shadows, the comet that unmade light. It no longer belonged solely to astrophysics. It had entered the realm of narrative, a story humanity told itself to grapple with its own fragility. In this way, Atlas transcended its physical presence. It became a symbol etched into the collective imagination, not just a fragment of rock from another star system, but a mythic messenger, a reminder that the cosmos will always remain partly veiled. Long after its orbit carried it beyond sight, its legend remained a shadow that grew brighter in absence, teaching that sometimes the most powerful revelations are found not in knowledge, but in silence. As the memory of Atlas settled into the human imagination, one truth remained unshakable. More questions had been born than answers. Each fragment of data, each corrupted frame, each irregular pulse carried implications that reached far beyond the comet itself. Atlas had come and gone, but the riddles it left behind continued to multiply. Scientists asked, what exactly was silenced? Was it merely our machines, or the very capacity of measurement itself? If observation collapses in the presence of Atlas, does that mean reality holds regions where knowledge cannot exist? And if so, how many such regions drift unseen across the galaxy? Astronomers wondered, are there more like it? Was Atlas a lone traveler, or the first of many? If interstellar space is seeded with such objects, how often might they brush against our solar system, and how many have already passed unnoticed? If the anomalies echo those of Oumuamua, was this sequence of visitors a coincidence or a pattern? Philosophers asked, what does it mean to live in a universe that hides? Humanity has long celebrated discovery as destiny, assuming that persistence guarantees knowledge, but Atlas showed otherwise. It reminded us that the cosmos is under no obligation to reveal its workings. Perhaps our search is less about finding answers and more about learning to live with absence. Theologians posed their own question. Was Atlas a messenger, not in the crude sense of aliens or divine will, but in the broader sense of symbol? A reminder that even at the height of technological power, humanity is small, fragile, dependent on forces it does not control. The Blackout became a sermon in silence, a lesson written not in words but in refusal. And beyond all of these lay the most haunting question of all: why now? Out of billions of years, why should such an object pass during the brief window of human existence when telescopes and satellites stand ready? Was it pure chance, or did the timing itself hold meaning? Atlas departed, trailing not a tail of fire, but a constellation of questions. And as those questions multiplied, they reshaped the way humanity looked at the night sky. The stars were no longer only guides or mysteries waiting to be solved, they were guardians of secrets, some perhaps never meant to be known. In the wake of Atlas, the cosmos seemed larger, stranger, more alive, and the questions it left behind may endure far longer than the comet itself, echoing as reminders that every answer humanity reaches for is surrounded by shadows, and that sometimes the shadows speak loudest. The echo of Atlas did not fade with its departure. Instead, it grew into a presence that lingered in silence, haunting observatories and classrooms, reshaping the way humanity thought of the cosmos. Scientists still passed the fragments, poets still reached for metaphors, and the public still wondered whether the Blackout was chance, defense, or destiny. Yet beyond the questions, something deeper remained, a sense of awe tinged with unease at the sheer mystery of existence. Atlas had shown that the universe is not merely vast but layered, with regions that resist light, resist knowledge, resist comprehension. It had reminded us that science, for all its triumphs, is fragile against the immensity of the unknown. More than that, it had revealed a truth most unsettling, that the cosmos is not obligated to be legible. Some doors may remain closed, no matter how many times humanity knocks. And yet, within that silence, there was also beauty. The Blackout did not erase curiosity, it deepened it. The refusal of Atlas to yield its secrets became itself a kind of answer, one that pointed less to what we know and more to how we live with not knowing. It was a reminder that mystery is not the enemy of science, but its companion, the shadow that makes every discovery luminous. In time, the story of Atlas would be told as both warning and inspiration. Warning that reality may hold boundaries beyond our reach. Inspiration that we continue to reach nonetheless, to stretch eyes and minds into the abyss, even when the abyss turns its face away. The silence of Atlas became part of our inheritance, a reminder of humility, of fragility, of the vastness that enfolds us. And so humanity returned to its nightly vigil, gazing into the darkness of the sky. The stars still burned, the galaxies still wheeled, and comets still crossed in slow arcs. Yet in every flicker of light, there was now the memory of the one that had passed unseen, the one that had erased our gaze. Atlas had come and gone, but it had left behind a scar, and within that scar, a question too deep to close. In the end, perhaps that was its gift, not knowledge but wonder, not clarity but silence. A silence that echoes still, reminding us that we live not at the center of understanding, but at the fragile edge of an infinite, unanswerable night. The story of three, I, divided by Atlas, fades like the comet itself, drifting beyond our reach, its mysteries folded into the endless fabric of the cosmos. What began as a scientific pursuit ended as something more elusive, a meditation on the limits of perception and the quiet defiance of the universe. The blackout was never explained, not fully, and perhaps it was never meant to be. In its silence, humanity found not failure, but reflection. Close your eyes and imagine the night sky. The stars shine as they always have, ancient fires scattered across the black. Yet somewhere in that darkness, memory lingers, the memory of an object that came from elsewhere, brushed against our world, and vanished. It left behind no tail, no trail of light, only questions. And in those questions lies the essence of wonder. Perhaps Atlas was a messenger of physics, yet unknown. Perhaps it was nothing more than exotic ice, shaped in alien conditions, misunderstood because our tools are still crude. Or perhaps it was a reminder that not everything can be grasped, that some truths remain hidden until we are ready, or until we accept that readiness may never come. The cosmos is silent tonight, but not empty. It holds secrets that watch us even as we search for them. Atlas has gone, yet its echo remains, a whisper that not all mysteries will unfold, a reassurance that the unknown is vast enough to cradle us, to humble us, to remind us that discovery is not the end of wonder, but its beginning. And so we rest beneath the stars, knowing that beyond the edge of sight, the universe continues its slow, secret dance. A dance we may never fully learn, yet one we are privileged to witness in fragments. Sweet dreams. Sweet dreams.